Hi folks, it's Andrew Kilpatrick here, and today I'd like to do a little quick video on USB. We'll see how quick it is at the end, but basically USB MIDI is something that anyone who's into audio and music has probably experienced, whether they knew they were using it or not. There may have been some problems with it. It might have worked well. It might have been confusing as to what was really happening. So what I'd like to do today is maybe give a little bit of shed some light, I guess, on kind of a bit of the basics on how USB works in general, and also how USB MIDI specifically works, because USB MIDI is a class compliant standard, which means that if your device supports the USB class, which is defined by the USB people, then you don't need to have any special drivers, which is cool. If you're doing your own DIY project, you can make a device like this or whatever that just plugs directly into pretty much any computer or phone or tablet, and it should just work by itself. With no, you don't have to publish anything for the customer or user to install on their computer. It should just fit within the scope of what's already there. So for this demo, I'm using this little Akai MPK Mini. This is just a little controller keyboard. It has USB MIDI here. And I'm also using this thing called the Teledyne LaCroix Mercury T2. This is a USB signal analyzer. So what happens is you plug your device through here. It has 2 ports on the front, and that goes into the computer that you're plugging the actual device into. And the second port, this is also a USB port that goes out to either the same computer in my case, or you can plug this into a different computer, the one that's going to actually listen to the communication between the device and the host. So let's just clear up some terminology first. First of all, this isn't talking about any of the sort of more modern USBs, USB-C, USB 3, and all that kind of stuff. As far as I know, they are sort of a superset, or I guess, they include this kind of USB, plus they have extra features as well. I'm not familiar with those in more modern formats. Most of the work that I do involves stuff like this, and audio devices, which are, for the most part, can still work depending on what you're trying to do, using the older USB standards like USB 1.1 and USB 2, just to make it clear. So the thing about USB, though, is it's really complicated, and if you really want to dig in and do it from scratch, there's a lot of stuff that you have to read. So this isn't designed as sort of like an instruction tutorial on how you would do it, just some basic tips on kind of how it works and what things are called. So firstly, let's talk about the connectors and the directions of the signals. Okay, so on the side of your device, you have a connector that this kind of cable plugs into, the sort of square connector with the beveled edges on one side of the plug. That's a USB-B connector. That always goes on a device, which is like this, something you would plug into your computer. On the other end, you have this kind of connection, and this kind of plug goes in it. That's called USB-A, and you can see it says A right there. That is for things that are hosts. So these are going to host a device. In the classic case, of course, you have your computer has these rectangular A ports on it, and you plug devices into it. Your computer is a host. On your motherboard, it has a host controller, which is a chip that connects to all these devices. You may have a USB hub, which has a bunch of these. That's another way you can connect more devices to a single port as well. But that's really important because this kind of host-device relationship is basically part of what USB is all about. Now, I know there are some exceptions to that, especially when you want to plug, let's say, phones into other things. A phone could be a device or a host. They also have what's called USB on the go, which means that you can plug 2 things together with the same cable, same connector, and they'll figure out who's in charge. But in this case, what we're talking about is a computer with a device like this plugged into it. In that case, this is the device, the computer is the host. Now in this case, it just runs through this box so we can watch the data traveling between the 2 devices, or the device and the host, to be clear. So let's talk a little bit about what happens when we first plug in our device. And I'm going to switch over to the computer and show you the tool that I'm going to use to show you what's happening. Okay, so this is a program that goes with that silver box, the Teledyne box. And this is the software that basically can record and analyze the USB data as it's traveling back and forth between the device and the host. The host is always in charge of all the communication. So let's just start with something really simple. What we're going to do is I'm going to hit record in the software, and then I'm going to just plug in the keyboard. And we'll wait a second for stuff to happen, and then I'll press stop, and we're going to switch over and have a look at what we got. So there's different kinds of packets that you can see here, and let me just hide some of the ones that we don't want, and we'll switch over like this. So here we have a list of the packets, or these are actually the transfers, which include multiple packets, as you can see. But transfers are like an entire little conversation, all wrapped up into one. And they have different types, and they have different ports and endpoints and so on. So let's just go through it really quickly, because this software is really cool. It can actually decode what all this stuff means. So when you first plug in the device, this is the first thing that we get. I'll move this up a little bit so we can see a bit more of what's happening. The first thing that happens is that you get a device descriptor. This is the host. Notice that there's no address number here. Every device that you plug into your computer gets assigned an address when you plug it in. So if you have a hub with a whole bunch of ports, if you go and look, all your devices will have been given this is a temporary address when the system is running, for instance. So at the beginning, it doesn't have an address yet. The computer has said, hey, who are you? What are you all about? And what you can see here is, and these are the names of the fields down here on the left-hand side. This is like if you were to look in the USB spec, you would see these names listed. So what do we have? We've got a descriptor. It says what kind of device it has, how big is the descriptor, and then there's some data here. So what format of USB, what specification version? It's a USB 2.0. What device class? Doesn't have any at this point. And it says how big can an endpoint be? An endpoint is like a buffer that receives data or sends data between a device and a host. And everything that you want to send and receive goes in and out of endpoints. And then you'll see, here's the important stuff. Here's the vendor ID. The vendor ID 2536, or actually in hex it's 09E8. This is a number that gets assigned to the manufacturer by the USB people. And this one's assigned to Akai Professional Musical Instrument Corp. And this is the product ID. This is assigned by the manufacturer, so they must have a whole bunch of other products with other numbers, or lower numbers, I would imagine. So they're allowed to assign any number in this range. This is a 16-bit number, so they can have up to 65,000 products. This is a release number. I don't know about that manufacturer. This is saying there's some strings with some more information, and you can go and get those. So this is the very, very beginning of the communication, that it just says, here's what I am. You need to get more information if you're going to want to know more about me. So then the next thing that happens here is that the computer says, I want you to use address 7. So it's just sent this message here, and that's been sent to the device. The device comes back and responds on device 7 now. You can see the computer has now requested the device descriptor again on address 7, and here is the same information again. I don't know why that does it like that, but that's just the way it goes. And then if we scroll this down, here's the interesting part. This is the configuration descriptor. So this is going to tell the computer a bit more about what kind of device it is and what driver it might need. So for instance, the First things here, it says how long the configuration is, how many interfaces it is. An interface is like different drivers can connect with different interfaces, and they can support different kinds of data at the same time. So that's kind of like how you can have a device that, let's say, does MIDI and audio in the same device. There's one configuration, there's no strings, and then it says this is the power. So for instance, it says this is reserved, self-powered, no, because that bit is off. So that means it's bus powered. That means that you need to provide power through the USB cable. There's no external power adapter. And then the maximum power consumption is set to the highest value here, which is 500 milliamps. Now I think if you have USB 3, for instance, you're allowed to have more power than that. But in this type of USB, you can only have up to 500 milliamps. Now that's not saying how much it will use. That's just saying that you need to be plugged into a type of port that can supply at least that much. So it might use that much, it might not, but that's what the device says it wants. If the port can't provide that much power, then it won't continue on because it may not work. And then there's some more descriptors here. This is a continuation, sort of. And it has all kinds of information. I won't go through all this stuff, but it has information about the kinds of endpoints, the kinds of data, how many packets or bytes can go in each packet, and so on. Here's an audio, MIDI, streaming, etc., etc. This goes on and on. This is the hardest part I've found when you're making a USB device from scratch. This is the hardest part to get right, because all of this stuff, all these interface descriptors and endpoint descriptors have to be set just right for a computer like a Windows machine or a Mac, for instance, to be happy with what your device is pretending to be, or not pretending to be, but how it presents itself for the built-in drivers that come from Microsoft or Apple or whatever, for them to be happy and say, oh yeah, I know what to do with a MIDI device, or I know what to do with an audio device. Because those kinds of systems are proprietary, it's sometimes hard to figure out, like, if your device plugs in and it's not working, it's hard to figure out exactly what is wrong. Like, one of these bytes might be set to like a value that it doesn't understand in the driver, etc. So a lot of time with a brand new device or a brand new project is spent kind of staring at these numbers and comparing them to some documentation and stuff to try to figure out exactly what's going on. So that's kind of the frustrating part. Okay, let's do one more recording, and then I'm going to show you some stuff. Actually, no, let's look at the stuff first. So this is the USB MIDI device class. If you, let's say, want to make your own MIDI device and have it just work on a computer without any drivers, this would be the device class that you would implement. There's a lot of information in here. But what I've found is the easiest way to get something that works, especially when you want it to work with things like Windows and Mac, is to look at existing devices and see how they're working. As far as I know, that's kind of how it goes. You know, you find something that's similar to your device, you may have to make some changes, but you would plug that one in, look at what it's reporting itself as, and basically know that obviously whoever made that probably knew how to make it work properly with all the operating systems, especially if it's a commercial product that's been out for a while. And then you can go from there. And then you can also, there's a lot of information in here, but basically, yeah, learn by example. That's the idea. Okay, USB MIDI is just like regular MIDI, except it has a little bit more information associated with each packet or each bit of data that gets sent. So let's just take a quick look at this here, because this will make sense in a moment when we watch the data that's going back and forth between the keyboard and the computer. For instance, these are 3 MIDI bytes, which would make up a normal kind of MIDI message. And then there's this extra stuff here. So if you have a MIDI interface, and most of you have probably, if you're into music, you probably know you can buy MIDI interfaces that have more than one MIDI port on them. And this is how this works. So for instance, the top byte, the first byte that gets sent, has two parts to it. It has the cable number, and this is 4 bits, and it has the code index number, and this basically says what these next 3 bytes will mean. Because USB MIDI is always sent using a 32-bit packet, that means even if your MIDI message, and if you look in some of my other videos, you can see how the various kinds of MIDI messages work. Even if your MIDI message has only 1 byte, you always send 4 bytes at a time, just because it's just easier. That's just how it works. So this code index number, which is, I call it the CIN number, is basically what tells your software or whatever is decoding the MIDI. In the case of a computer, it's usually the driver decodes this part, and you don't actually see any of this stuff when you write your own MIDI program on the computer. You'll just actually get that stripped off, and you'll just get the MIDI data however it's supposed to be formatted on the port that you opened. So for instance, if your device is a MIDI interface with 2 ports and your program decides to open just port 2 or something, you'll just get the MIDI data that came in on that port. But when you're working at a lower level, or if you want to make your own device, let's say you want to make a microcontroller project that has like 3 or 4 MIDI ports on it, then you have to deal with this kind of stuff. So these are all the different kinds of messages that you can send. So what you're supposed to do is you're supposed to tag the message that you're sending with, for instance, if you're sending a note on, you send CIN as an 8 in hex. Well, same in decimal too, and then you're supposed to fill 3 bytes in here. So this idea of running status that we would normally do on like a MIDI DIN cable, normally you would send fully formed messages here. Now, because you can use this protocol to relay messages from a normal MIDI cable, it is also possible to send single bytes. So for instance, you could just send any 2-byte message, any 3-byte message, like messages like this, messages like that. There's also single bytes. So if you really want to, you don't even have to worry about any of this. You could just send 1 byte at a time and only use MIDI 0 here and just send full messages 1 byte per packet. But that's kind of wasteful. The whole cool thing about USB MIDI is it's way faster than DIN MIDI. So, I mean, you might as well use this. So what I use on my system is when I have fully formed messages in my firmware, what I do is that I look at the type of message and I choose the correct code and build an entire message at once if possible. So you can see these are all the normal kinds of MIDI messages, channel messages, and so on. And you'll notice that these all match the same status codes that you would get if you're just looking at the MIDI message. So it's kind of like there's a bit of repeating of data. The cable number is a 4-bit number that can be one of 16 values, and that lets you basically have 16 different MIDI ports on the same endpoint, which is basically all these bytes end up in one place, and we'll see that just in a second. Okay, so let's switch back here, and I'm going to hit record again, and actually I've got a program here. Let me run this program, and let's see. Okay, there's some notes. There's a pitch bend and stuff. This is just a little MIDI debugger that I made. Okay, if I hit record, and we'll switch over here, and I'm gonna move some stuff and hit some buttons and stuff, and then we'll switch back and see what we got. All right, so when we look at our data, there's all kinds, oh, it's parsing it right now. Okay, and we're about to see what we got. All right, there's all this data here, all this stuff where nothing's happening. This is because every millisecond, or more frequently if there's extra bandwidth, the host will ask the device, because the device can produce data. The device can't just send data whenever it wants. It has to be queried to send its data. So the host says, hey, do you have any data? And it says, nope. And then it does it again, and it does it again. And you can see the spacing between these is really, really small amounts of time. Much more than once per millisecond, actually, many, many times per millisecond. So this program has some buttons that you can click to get rid of some of that stuff so that you're really only seeing the stuff that you want. So this is individual packets that we're seeing here. And if you click on one of these, you'll see the raw data that's in there. If you switch over to this, you'll see a bit more data in a way that's that makes sense for us. So for some reason, it doesn't know how to decode MIDI. I thought it should know that because it's a class standard, but anyway, it doesn't. So if we look in here, we'll see here's one of the times when we move the pitch bender. So here's our pitch bend value, and here's our pitch bend message and the channel, and we're on, this is the E, we're on cable 0, you can see here, and the E means that this is the pitch bend type of message. This is the CN number, and this is the cable number. And there's all the messages that we got. Let's see if I can find somewhere I hit a key or something. Nope, lots and lots of pitch bends. Okay. Let's see, what do we get here? Oh, here's one of my note messages. Okay, so here's a note on. Here's also note on. This is the actual MIDI data. Here's the key number, and this is the velocity. And then probably when I let go of it, you'll see another message. Yeah, see, this is a note off message. Channel 0, which is this nibble here. And then this is the same note, and this is the off. So that's basically how it works. So you can see with a device like this, you can sort of watch what's going on in between the device and the host. You don't need to have hardware like this. You could actually have some software that decodes this. I know Wireshark, I think, can decode MIDI and USB messages and stuff like that. There's also some other tools, both free and not free tools that you can use to do the same thing. The part that you can't do easily with software, though, is that when you're first connecting your device and wondering why it's not showing up properly on your computer, that can be a bit difficult to do without sort of a hardware solution. So I always kind of pull this out at the last resort when nothing else is working. So anyway, that's basically it for this video. I hope that was interesting, and I hope that you learned something. USB is one of these kind of necessary evils, I would say. It's not ever that fun to work on projects that use it, but once you get it working, you can add a lot of functionality to your device. Also, the cool thing is when you have a device like this, it just plugs into the computer and powers off the computer, so you can really make cool, simple devices that, you know, work with only one cable and do some cool functions. So anyway, I hope that was useful, and leave me some comments and subscribe if you like this video, and let me know what else you'd like to learn about, and if it's something I know, I'll make a video about it. Talk to you later.